every point on the sphere given just one name and just one of 6 colors, we are ready to take the entire sphere apart. Every point on the surface corresponds to a unique line of points below it all the way to the center point, and we will be dragging every point's line along with it. The lone center point we will set aside. Okay, first we cut out and extract all the yellow poles, the green starting points, the orange up points, the blue down points, and the red and purple left and right points. That's the entire sphere. With just these pieces, you could build the whole thing. But take a look at the left piece. It is defined by being a piece composed of every point accessed via a sequence ending with a left rotation. If we rotate this piece right, that's the same as adding an R to every point's name. But left and then right is a backtrack. They cancel each other out. And look what happens when we reduce them away. The set becomes the same as a set of all points with names that end with L, but also U, D, and every point reached with no rotation. That's the full set of starting points. We have turned less than a quarter of the sphere into nearly 3/4 just by rotating it. We added nothing. It's like the hyperwebster. If we add the right piece and the poles of rotation in the center point, well, we've got the entire sphere again, but with stuff left over. To make a second copy, let's rotate the up piece down. The down-ups cancel because, well, it's the same as going nowhere, and we're left with a set of all starting points, the entire up piece, the right piece, and the left piece. But there's a problem here. We don't need this extra set of starting points. We still haven't used the original ones. No worries, let's just start over. We can just move everything from the up piece that turns into a starting point when rotated down. That means every point whose final rotation is up. Let's put them in the down piece. Of course, after rotating, points named UU will just turn into points named U, and that would give us a copy here and here. So as it turns out, we need to move all points with any name that is just a string of U's. We will put them in the down piece and rotate the up piece down, which makes it congruent to the up, right, and left pieces. Add in the down piece along with some up and the starting point piece, and, well, we're almost done. The poles of rotation and center are missing from this copy, but no worries. There's a countably infinite number of holes where the poles of rotation used to be, which means there is some pole around which we can rotate this sphere such that every pole hole orbits around without hitting another. Well, this is just a bunch of circles with one point missing. We fill them each like we did earlier, and we do the same for the center point. Imagine a circle that contains it inside the sphere and just fill in from infinity. And look what we've done. We have taken one sphere and turned it into 2 identical spheres without adding anything.